exact average temperature is equal to the limit as, what goes to where? Say it one more time. And that's the number of temperatures, correct, approaches infinity of 1 over b minus a times the sum of all those temperatures. Okay, now, remember limit law said, if you know a constant, which is what this is, you can move it out front. So I'm gonna do that. I'm gonna move that out front. And I'll have 1 over b minus a times the limit as n goes to infinity of this sum. Alright, now there's this guy that is your best friend in calculus. What's his name? Simpson, no.
Calculator?
Riemann. Riemann made a connection here. He said, anytime that you have the limit as n goes to infinity of a sum like this, and you have a function here and a change in something here, you can change it to this. 1 over b minus a times the integral from a to b of your temperatures times, well, instead of delta at t, I'm going to say dt. Now, I'm going to call this capital T, T of little t, because it's a temperature in terms of time. Oh, so look, now we have another application for the integral. We can find average temperatures as long as we have a starting point and an ending point, and we have a function that represents it, then I can come up with it. Now, I don't have a function for those numbers that I made up, so I could approximate this with the trapezoidal rule, like you said, Jenna. But if I want the exact one, I need the actual function right here. So this is going to represent the temperature right here, depending on the time, at any time. And we are going to find the average temperature. So now I would like to talk about this more broadly and just say this. The average value of, now I'm going to put an F here, but this F can be anything you want to find the average value of. If I want the average value of the temperature, that's what this is going to be. The average value of, what else can I say? Anything, average velocity, average, whatever comes out, that's what you can put for your F right here. So that can vary. So this is what you're trying to find. I'll put a little question mark. And we'll do this on the interval from A to B. So the average value, whatever that happens to be, is equal to 1 over b minus a times the integral from a to b of whatever you're trying to find the average of dx. Okay, so this can vary. This changes to whatever you're trying to find, whatever we're trying to find the average of. So I got an example. My language here is kind of bad, isn't it? I ended in proposition. Okay. So find the average value. I'm going to start simple. Let's find the average value of the function f of x equals 1 plus x squared on the interval from -1 to 2. Now I drew a picture of this down below because I want to have some people take some guesses. My picture's not on the axis. Okay. Now, will you take a look at this? And we are trying to figure out from, let me put this in blue, I think. From here, what did I say, -1? -1 to 2. All right. Okay, here's 2 and here's -1. What do you think that the average value on that is? When I say value, I'm talking about the y coordinates. Now, Now, this y coordinate is 2, and it goes down to 1, and then it looks like it goes up to 5. 1, 2, 3, 4, 5. Any guesses? Would you think the average? Now, I can't take every single y value in between there because there's an infinite number of them, and add them up and divide it by that number. So I'm going to have to go back to my formula. What do you think? What's the average? Just a guess.
2.5.
2.5. So we think the average value of this function is about, these are guesses. I heard 2.5. What did you think it might be?
3.5.
3.5. Anybody else see anything different?
I think it's gonna be 4.7.
Now, that seems high to me, Erin, and I'll tell you why. Because the only time, this is 5 right here, here's 4.7. Do you see how most of the values are below that? Now, 2.5 is right here. Do you see how most of the, you're trying to get the values to be about the same.
Oh, I thought we were
below.
finding, never mind, I'm finding the wrong thing.
Do you understand now?
Yeah, I got
The
it.
average y value, the average value of the
Oh.
function.
Okay, yeah.
So this y value is 2, this one is 1, this one is 5. You guys see what I'm saying? Okay, so let's figure it out. Then we'll come back to the picture and talk about it again. So the average y value is equal to 1 over, what's b minus a? What's b? 2 minus a negative 1 times the integral from
Negative
2 of that function. I'm going to write this in here. Dx. Did you understand the setup on that? Okay. Could you put your calculator out and just see if you can put this in? I am going to write this as well, so I'm find this.
I'm confused, though, when you bring on something, are we finding like the area under the curve?
No, I'm going to explain that in a second.
Okay.
I'm trying to find the average y value on that curve, not the area. I'm going to make it relate. I'm going to relate that in a second. But
Okay.
right now, just think in terms of the average of the y values. 2. Oh, so you were close. You were close. Did you guys get this? Or is she too fast for you? But you have no problem putting that in? Okay, so that's a 2. Now, Erin, I'm so glad you asked that because I'm going to show you how that relates to this graph. Okay? Now, here's what I'm going to do is I'm going to go and shade this area since you were talking about area. And that area is not 2.
It's 6.
It's 6, yeah, it's 6. Because we're using 1/3 of that area. Now, I'm going to figure out, this is a 2 right here. I'm going to go ahead and draw a rectangle made out of that 2. It's hard to see that 2. So this is 2. And I'm going to show you that right here, this is 1. That is, let me dot it on it. You see that right there? What's the area of this rectangle right here?
We have the dotted line.
I'm talking about this rectangle from -1 to 2.
6. 6.
So wait a minute, I hope I can put this together for you. Do you see that the area under this curve from -1 to 2 is 6? And I happen to find the place that's just the right height for that rectangle, that when I put it under here and draw that rectangle, just one rectangle, it gives me the exact area. Do you remember we used to ask this question all the time? No, I'm going to go down here, I'll come back.